Hello world and welcome to this new tutorial. My name is Nelson Fojo, and in today's video we are going to be solving the GCE advanced level computer science 0795 paper 3 June 2024. To get the paper, visit the website cameroongcerevision.com or download the app Kaolo from your Google Play Store and get ready. We have already covered the section A. Visit the link in the description below to get the solution to section A. And given that the paper is supposed to be solved in 2 hours, that means we have barely 1 hour to finish the section B. So without wasting time, we are going to dive into the short notes. To begin, we are going to start with important definitions you need to know in order to answer the question paper. The first one is an algorithm. An algorithm is a step-by-step procedure for solving a problem or performing a task. It provides a clear set of instructions to achieve a specific result. Next, we have a pseudocode. It is an informal English-like description of an algorithm that does not make use of strict syntax rules of any programming language. The control structure, it is one that specifies the manner in which statements are executed in an algorithm or any program. We have control structures like the iteration control structure, the selection control structure, and the sequential control structure. We're going to look at that in other videos. Next, we have a local variable. It's a variable that is declared and used within a specific scope, typically within a function, method, or block of code. It is only accessible within that scope and not visible or usable outside of it. Next, we have global variable, which is declared outside any function or block of code, typically at the top level of the program. It is accessible from any part of the program, including inside functions, classes, or other blocks of code. Next, we are going to look at functions. They are reusable block of codes that perform a specific task, takes input or not, processes it, and often returns an output. Let's look at an example. Here's a basic example of a function that adds 2 numbers. The pseudocode is given on your screen. You can see it takes as parameters a and b and returns their sum, where a and b are any 2 integers or any number given by the user. Next, we have a procedure. It is a set of instructions that performs a specific task. It is similar to a function but typically does not return any value. For example, a procedure that prints a greeting message but does not return any value. Like here we have the pseudocode procedure, prints greeting, name as parameter, print hello name, and end procedure. There's no return statement like in a function. The main difference between a function and a procedure is that functions do return values, whereas procedures do not return any value. Next, we have a parameter. It is a piece of information that you pass to a function or method to customize its behavior. Think of it as a way to provide input to a function so it can work with specific data. For example, in the print greeting procedure we saw, the name is a parameter. Also, in the add function above, a and b are the parameters. Look at the pseudocode we had. In the function add, a and b here are the parameters which are inside the parentheses of the add function. Next, we are going to look at argument. An argument is a piece of information that you pass to a procedure or a function to customize its behavior. Parameters allow you to provide inputs that the procedure can use when it runs. For example, when calling the print greeting procedure, Bayon is the argument passed to the name parameter. Like when you want to pass any value to a function, you pass the argument and the function receives it here, but here they are parameters. We are going to move with other definitions like standard library. The C standard library includes headers like stdio.h, stdlib.h, string.h, etc., which provides functions for input and output, memory allocations, string manipulations, and more. The syntax to call a library is #include library.h. Think of a library like a storage location in your memory or in your computer that stores functions or classes or procedures, whatever. For example, the stdio.h library stores functions like printf and scanf. To continue, you're going to see you're going to move with a custom library. In C, custom libraries are collections of pre-written codes, functions, and definitions that the developer creates to encapsulate specific functionality or features tailored to a particular application or project. The syntax of a custom library is #include, you have quotes, filename.h. The main thing to retain here is that we call custom libraries using quotes, and we call standard libraries using angle brackets or chevron. Good. Next, we are going to look at another definition. We are going to enter arrays. First is a 1D array or one-dimensional array. It's a collection of elements of the same data type stored in contiguous memory locations. It can be thought of as a list of items. The syntax to initialize or declare a 1D array is, here you have the data type. It could be an array that stores a list of integers, an array that stores a list of numbers, or an array that stores a list of decimal numbers. So you put the data type here. Next, you go to the array name. In the array name, it's just the name of your list, then the size. Let's look at an example. Int numbers 5, which stores, is a declaration of an array which stores 5 integers. Here you can have, we have declared. Now to initialize, here we have int numbers 5 equals 1, 2, 3, 4, 5. We have initialized and filled the array with 5 elements containing numbers, or let me say integers, from 1 to 5. Next, we can see here that we can initialize an array without specifying its size, so it's optional, it depends on you. The same array was initialized here, the same size, but the size was not mentioned. Good. So we are going to continue with a visualization of how this happens in memory, and we are going to look at how the indexes. We can see here the elements of the numbers array are 1, 2, 3, 4, 5, and their respective indexes 0, 1, 2, 3, 4. That means if I want to access the element 4, I'm going to call it using the index 3. So that's how indexes are in C. We are going to look at an example. To call the element 3, I'm going to call printf %d, format specifier of integers, numbers 2. Here I am calling the element at position 3, but the index is 2. So always look at the positions as index plus 1. So if I call this, I just need to go to the third position, which is 3. It gives me the element at index 3. So you call arrays using their indexes. Next, we are going to look at 2D arrays or two-dimensional array, which is a collection of elements arranged in a grid or matrix format consisting of rows and columns. It can be visualized as an array of arrays. The syntax of a 2D array is simple. Data type, array names. First square bracket stores the rows, number of rows, and the second curly bracket stores the number of columns. For example, we are declaring a 2D array with 3 rows and 4 columns. You put the data type, the name of the array, which is matrix, the number of rows, and the number of columns. 3 rows, 3 columns. So you can just start drawing that. Now let's try and initialize this array with elements. Here we have int matrix 3, 4, rows, 3 rows, these are the rows, 3 and 4 columns, these are the columns. So to do that, you open your curly brackets, you open another curly bracket of a 1D array. So as we said, a 2D array is just a combination of 1D arrays. So the first 1D array represents the first row with number of items, each of them given the position of their columns. So you do that over and over, 1D array 3 times to give you 3 rows, and the number of columns give you the number of items on each of them, separated by commas. Let's try and look at how we can access elements. To access the element of the second row, third column, we call for the element at index 1 for the row and index 2 for the column. As I said, the index is one position behind the position itself. Good. So to call element 10, we are going to say element at index 0 for the row and index 1 for the column, which is the first row and the second column. Here is the first row, here is the second column. And now, as you can see, we have put an equal sign and we have assigned that value to 10. That means where we see 2, we are going to replace with 10. So that's how you change elements in a two-dimensional array. Let's now go to a visualization of the array. We are going to initialize it as a table or a matrix filled with numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And as you can see, it is a matrix of 3 rows and 4 columns. Let's look at the indexes. The index of the first row starts from 0 and ends with 2. Like index is equal to position minus 1. Same thing for the column. Index 0, 1, 2, 3. Good. So if you have understood how positions and indexes function, I'm going to ask a question, and you can go through the question, pause this video and provide your answer in the comments below. What is the value of matrix 2, 1? Name of matrix: index 2, 1. Index 2, index 1. What's your answer? Good. So if you have done that correctly, your answer should be 10. If you look at very well, for row at index 2, that means row 3, this is row 3. We go to row 3, which is here, 1, 2, 3, row 3, column 2, 1, 2. We are here exactly. So always use positions not to get confused, or you could use indexes. You draw your indexes and visualize it in a better way. You go to index 2 and index 1 for the column. You see column 10. So that said, we are going to dive directly into the question itself and start the question paper. We are going to begin the section B, which is the programming part of this paper, the title 4 in a line program. We'll just go through the question paper as fast as possible before starting. A Connect 4 or 4 in a line is a 2-player strategy game played on a 7-column by 6-row board. Each player has 21 discs of a given color, which he or she drops into one of the columns during his or her turn. The disc is dropped to the lowest empty cell in the column. The first player to align 4 discs of his or her color wins. The disc can be aligned vertically, horizontally, or diagonally. If the board is filled without any alignment, the game is drawn. We are to implement a variant of the Connect 4 game, which is played on a 5-column by 5-row grid with 2 players, player 1 and player 2. We use the character X for player 1 disc and the character O for player 2 disc. Task 2, understand the problem, 6 marks. A. In the space below, draw a table with 5 rows and 5 columns. On the left side of the table, number the rows 1 to 5 from top to bottom. Below the table, number the columns 1 to 5 from left to right. Make sure each grid cell is large enough to write any character in. B. In the table in task 2 above, show 4 different possible bin alignments using the X and O. There should be 2 alignments for player 1 X and 2 alignments for player 2 O, with no 2 characters placed in the same cell. C. To play the game, player 1 and player 2 make alternate moves. To implement this, a variable player is initialized to 0 and then incremented by 1 after each player's move. If player is divisible by 2, that is, its remainder is 0, it is player 1's turn to play. He or she is then prompted to enter a column number. Otherwise, it is player 2's turn and he or she is similarly prompted to play. Write a pseudocode fragment that uses a choice construct to alternate player moves as described above. Use the percentage or mod for the modulo division operator. 2 marks. Good. So we are going to finish task 2 before entering task 3. And a good method during the exam is to always go through the whole questions before starting. Else you might make a mistake that will take you a lot of time to recover. Good. So A says we should draw a 5 row by 5 column, and on the left of the table we number rows 1 to 5 from top to bottom, and below 1 to 5 from left to right, making sure that each gate set is large enough. Good. So we're going to start with A. I'm going to draw my tables. This is it. Number the rows from 1 to 5 on the left from top to bottom. Number the columns from the bottom from left to right, 1 to 5. So task A complete. 2 marks. Great. B says we should show 4 possible win alignments using character X and O, with 2 alignments for player 1 and 2 for player O, with no two characters placed in the same cells. So if you do that well, you're going to have this. This is the first alignment for character X, which wins. The next alignment for character X win. First alignment for character O, which is player 2, and the second. So this is 4 alignments with 2 winning positions for player 1 and player 2. As you can see, this is how the winning alignments are supposed to be positioned. Player X character X represents player 1 and character O represents player 2. Now these are wrong alignments. Putting your characters just anywhere in space is extremely wrong, because the instructions told us that when a character plays, it goes to the lowest empty cell in the column. And as you can see here, there are a lot of empty cells in this column. So this is a wrong alignment. Next, this is another wrong alignment where you put 2 same characters or different characters in the same cell. You are not allowed to do this. We are going to go to the next question. That means we already have 4 marks. The next question says, to play the game, player 1, player 2 make alternate moves. To implement this, a variable player is initialized to 0 and incremented by 1 after each player's move. If player is divisible by 2, that is the remainder is 0. It is player 1's turn to play. He or she is then prompted to enter a column number, otherwise player 2's turn to play. So understanding this question, we first initialize a variable player to 0, then we have to increment that variable by 1 after each player's play. So we're going to first ask if player is divisible by 2, then we prompt player 1, else prompt player 2. Good. We're going to do that. C. This is the variable player being initialized to 0. Condition, since we said we should use a selection construct. If player mode 2 is identical to 0, don't forget this is pseudocode, so don't mind the syntax of C, Pascal, or any programming language of choice. We are going to say output player 1, enter the column number, input a column number. So we are taking the column number of player 1 if the player mode 2 is 0. Else, we increment the player by 1. Else, we output player 2, enter a column number, input, we take that column number, and we increment player by 1. We end our if. So this is just the fragment of the code that's been asked, and if you do this exactly and if you do this correctly, you're going to have a good score, which is 2. And that's it. We are done with task 2. Okay, next we move to task 3, which is the implementation. This is the most critical part of the exam, and the first step to do, as we all know, is to go through the whole task questions before starting. Good. So A says, in your favorite editor, declare a global variable C4grade and hold the connect4 grade. Its data type is tboard, which is a 5 by 5 array of characters. B. Write a programming language function or procedure called displayGrid, where argument A is of type tboard. A subprogram prints the content of array A 5 times per line. It displays its row and column numbers as described in task 2A. Read lines are not required. Visit task 2A up. The files align.h and align.pass in your candidate folder contains definitions for two subprograms called empty grid A and is align A, which are called in the subroutine play game. Comments in the files explain what the subprograms do. Pascal programmers open the file align.pass, copy and paste the content in appropriate places in the program. C programmers add the line #include align.h at the appropriate position to your program. Copy the file align.h into the same folder as the program you are writing. C. Convert the algorithms in figure 1 and figure 2 into a function and procedure respectively. Figure 1 is a function and figure 2 is a procedure. Place them in the appropriate places in your program. 9 marks. Wow. D. In the subprogram play game, convert the pseudocode segment tags to C into a programming language code and insert it where indicated. Make the following adjustments to the program. Add statements which read for each player the column number they have entered into the variable call. Add two assignment statements which assign for each player the character X or O that represents them. E. In your main program, call the subprogram display grid to display the Connect 4 grade and subprograms play game to let users play the game. Make sure your program works. Save your source code as printout2a and then print a copy. Run your program so that one player wins. Take a screenshot of the output, save it in the printout2b and then print a copy. So next we have the figures that we're talking about, figure 1 and figure 3, figure 2. Okay, figure 1, 2 and 3. Figure 1 is a pseudocode or the drop disk. It returns something. So drop disk is a function. It takes as parameters a call this, initializes the code. You can see every instruction. For now, we believe you're not understanding anything, but in the conversions, you're going to understand more. Insert updated code segment from tax 3D here. Tax 3D talks about convert the pseudocode segment tax to C, which is a pseudocode we wrote here. So we're going to insert it here and convert into C or Pascal, depending on which language you're going to choose. You can see the procedures, continuous, and that's the subroutine. Next, figure 3, variables used. You have a C4 grid. Some variable use C4 grid, a 2D array to be used as the Connect 4 grid. Declare it as a global variable. Rows calls. The number of rows and columns, bracket 5, in the Connect 4 grid. Define both as symbolic constants. These are macros. A 2D array of characters called the column player is playing. The column a player is playing. Okay, yeah, the column number. Disk. The disk a player uses X or O. Done. The value returned when a disk is dropped. 1 for successful drop, 0 for an unsuccessful drop, and -1 for an invalid column. Play disk. Counter for total number of disks placed in C4 grid. Okay, a counter. Alright, so the counter should be for a 5x5 should be 25 maximum. Player. Used to alternate between player moves. Alright, we saw that. Stop the game. It is set to 1 when a player has won. Okay, so after reading extremely fast, we go to the beginning as fast as possible. A says, in your favorite editor, declare global variable C4 grid to hold a Connect 4 grid. Its data type is T-wall, which is a 5x5 array of character, a 2-dimensional array of size 5x5. So I first open my code editor here, or my IDE, which is Dev C++. And after opening Dev C++, I'm going to create a new source file and press Ctrl S, store it in a particular location in memory, save as. Check exactly where I'm going to save it. In the desktop located in my candidate folder, which is Nelson Fojo. Good. and I'll make sure that I call this .c. Here I'll just say connect for game. Save. Now that our file has been saved in the precise location already, we're going to proceed with the first question, which says, in your favorite editor, declare global variable C4 grid to hold a connect for grid. Its data type is tboard, which is a 5x5 array of characters. Okay, so data type tboard. Good. Now the name of the array is C4 grid, as we saw in the short notes. The size 5x5 array. That means tboard here represents characters. You just do that, and each statement ends with a semicolon. Good. So we have the one mark. Next, B. Write a programming language function or procedure called display grid A, where argument A is of type tboard. A subprogram prints the content of array A 5 items per line. It displays its row and column numbers as described in task 2A. Okay, grid lines are not required. So we are going to start. I'm going to say void. Since it's a procedure, it doesn't return anything, it just displays. Display grid. It takes as parameter. Let's first put the data type of the parameter tboard A. It takes A as parameter, the data type tboard. Curly brackets, we enter the procedure. So to display an array, we know the normal function. First of all, declare an iterator for the rows and another iterator for the columns, I and j. Then inside two loops, we say for I starting from 0, I less than the number of rows. We saw a variable here which is called rows in capital. Yes, the number of rows or columns that both of them are symbolic constants, and the store 5, which is the number of rows and the number of columns. So we are going to define our symbolic constants first, so that as we use it, they come here. To use that, it's simple. We use a macro, hashtag define rows, the name of the macro, and the value it carries 5. We do the same thing for the next. We do the same thing for the next macro, which is calls, hashtag define calls, name of macro 5. So this is the only statements you see that don't end with any semicolon. So a macro is like a variable, but here it doesn't store anything in memory. What it does is simple. It goes through the code, and everywhere it sees rows, it replaces it by 5 immediately while compiling. Okay, so we continue. For I equals to 0, I less than or equals to rows. I less than rows because we know the index will live from 0 to 4. The index of our number of rows. So here we are dealing with indexes, I++. Okay, inside this for loop, we are going to iterate another for loop to iterate the number of columns. So go through the columns, so print the columns. We're going to say for j, so this is a syntax to display 2 by 2 array in C. J less than calls, j++. We enter. Good. So here it's simple. We are printing the array. So we're going to say printf format specifier %c, as it is a character, the parameter which is a, and the two iterators I and j to enter the specific indexes. So when I 0 j 0, it prints the element at item 0 0. Good. So this particular loop is going to go through each column, and this loop will go through each row. So after printing the first column, the first row, each element on the specific column, we need to go to the next line before printing the next row. So we're going to say printf \n, which is going to make us go to the next line. Here we need a semicolon, here is semicolon to end our statements. Okay, next, here we say we are asked to display the rows and the column numbers as described in task 2. So we have to display the row number and the column number before even filling or displaying the matrix or the game format. Okay, inside here we are going to print the row numbers. So we're going to say printf To print the whole numbers, we are going to put our format specifier, which is an integer %z, comma I. If you print I only, it's going to print 0, 1, 2, 3, 4. So we want that it should print 1, 2, 3, 4, because before printing the columns of the first row, we need to put the number before it. So we're going to put I plus 1. So it starts from 1, 2, 3, 4, 5. Good. So as it prints 1, it prints all the columns for that particular row. It comes to the next line, it prints 2. When I becomes 1, it prints 2 and prints all the columns for the second row. Next, we need to print down all the numbers below all the rows. So after printing all the rows, that means we need to go out of the row loop, which is this loop. You go out of the loop that prints the number of rows. That means at this level we have printed all the rows 1, 2, 3, 4, 5. We need to print the number of columns right at the bottom. I'm going to say print F. Put a space for the first one, another space just in case they'll put 1, 2, 3, 4, 5. Yeah, because here there's no loop that will help us print that alone. So you can do this and add a \n to make the code look beautiful and other items down not to mix up. Good. We are done with the B section. We have the 4 marks. Remove the files align.h and align.pass in your candidate folder contains definitions for 2 subprograms called empty grid, which are called by the subroutine, and is aligned a, which are called subroutine play game. Comments in the files tells the subprogram what to do. Okay, C programmers, add the line #include align.h at an appropriate position to your program. Copy the file list into your sim folder location they are writing. Alright, so we are going to add that line here because this is what we call our libraries. #include we set align.h. After including, we need to go and copy that file from our candidate folder into the sim folder location. This is the align.h folder. We're going to copy it. Okay, so we are going to copy this and paste in our candidate folder, which contains our C file. Pasted. Good. After pasting the file align.h into our folder containing the C program, we are going to continue reading. So we did that. There's no mark allocated for that. Okay, 4 marks. No, we did this already. No mark. Okay. C. Convert the algorithms in figure 1 and figure 2 into a function and procedure respectively. Function and procedure. Place them in appropriate places in your program. Okay, we have to convert. Okay, we are converting this into a function. We have sub drop disk done equals to 1 initialization. So we're going to do that together. Appropriate place in your code. We're just going to put it down. We are not yet in a main, so we continue. To start, we are going to write exactly what we saw, which is a function called the drop disk. It takes as parameter tboard a, int column, and char disk, as this is a character of either x or o. We start. We say int drop disk. Data type for the first parameter is tboard a. Next is int column, since it is a number of. Then we go to char disk. Good. We enter our function and we start. The first one was assigning define to 0, comma, and I. Let's check that. I to rows. I is equal to rows. Okay, we end with a semicolon and we continue. Now, what's next? What next? We have a condition. If column is greater than or equal to 1 and column is less than cos, then, so when we say if col is greater than or equals to 1 and call is less than or equals to calls, and call is less than or equals to calls, then okay, what happens next? Let's check that. While none is not equals to 1 and I is greater than 0, do this. So I'm going to say y inside our brackets. You see while done is not equals to 1. It is it's a syntax of C, and it's a double, and I is greater than or equals to I is greater than 0 from what I saw. Yes, I is greater than 0. What next? We enter the while loop and we check exactly what happens. Inside the while loop we have an if statement before and an else statement. You have if, there and if. Outside the if you have this. Good, so let's put that. If a of I and call is identical, so an empty string. It's a mistake here, excuse me, I have to close this. Okay, then a of I call is equals to this, then a of I call is assigned to this. In fact, this is equals to, it's the same thing, so let's just say a of I call is equals to this here. In fact, it's not the same thing. That's how we're assigning pseudocode. It's equals to this here. In pseudocode, you always see this arrow looking to who enters, so this guy enters this guy. That means in C, I'm going to say this guy is equals to this, and then is equals to 1. Now here you're going to see equal signs in conditionals. In pseudocode, usually by convention, equal signs in C are two double signs to signal identity. Assignation are arrows that goes like this, whereas comparison double equal to, when it comes to C, single equals to assign. Okay, so done is equal to 1. Always end with a semicolon, not to have a syntax error. Out of the if, as I said, we make I, we assign I to I minus 1. Good. So out of the if, we end the while, we go and put an else statement. The while ends here, so out of it, we have an else done equals minus 1. Good. So we continue as fast as we can. The next question, after converting, we are not done. After the if statement, you return done before you close the procedure. The if statement ends here, so we return done and close. Good. So after that, so next we move to figure 2. Here's our figure 2 with the pseudocode. It's extremely long, so the typing should be extremely fast as well. Sub play game, initialization, stop, place disk, player, and we call the empty create function procedure. Alright, so let's start. I want to first put some space here to make it okay. Void is a procedure, it doesn't return anything. I'm going to say void play game. Void play game, we open our parentheses and our curly bracket to enter. We have to start with the declaration int stop equal to 0, place disks equal to 0, and the player equal to 0. Next, we want to call it empty grid. Empty grid C4 grid semicolon. Okay, after initializing everybody, stop, place, disk, player, empty grid. Here we have a repeat statement. Okay, so we are going to use the repeat. We are going to read the repeat here. Repeat instead of the statement. Repeat until this happens. So that's a while loop in C. We are going to say while. The condition says while stop is equal to 1 or place this is greater than 25. While stop is identical to 1 or, which are straight numbers, place disk is greater than 25. We enter the while loop, which is our repeat until. The first one is we are converting the algorithm we had initially into a C code. The first thing to do is to, if a variable player has been initialized already, so the next we enter our structure. If player, if I have to put inside the parentheses, if player mode 2 is identical to 0, condition printf layer 1 turn to play. Okay, let's just put it like layers 1 turn to play. Enter a column number. Enter a column number, put this, put a space, and we allow the user to enter a column number. Put a scanf, which is the input function. Start with the format specifier %g to take it from the user, and the address, which is stored in variable column. From our code, variable code has not been initialized, and this cannot give when you don't initialize a variable. So we'll say int call, and we continue. We initialize call because here we can't use a function that will be initialized in the function. No, it's passed as a parameter. Disk is equal to, because as it plays, we need to know exactly which disk the user plays. This is equal to x, and we can go to the next line to make our code look good. \n. We end with a semicolon still. Then we have else, curly brackets. Guys, I advise you guys to use a lot of copy and pasting here to gain in time. So we're going to copy that and paste it here. We're going to say player 2 turn to play, enter a column number. We're going to score here, but his character noun is O. Let's check it back. We have stored into a variable that we know already is the call variable. This was just for formalities and we weren't specified anything, so the main thing here is to see how we play. Good. We are done with this, but we need to increment the player. We're going to say player plus plus, or player is equal to player plus 1. Player plus plus here, same thing here. Player plus plus, which is the same thing as player is equal to player plus 1. So increment our variable player. After inserting the code fragment, insert the code fragment. Done is equal to drop this C4 call disk. Do that. We just convert that out of the fragment. Out of our if, we say done. Done is equal to drop disk. Okay, we are going with the argument C4 it. While passing an argument, it's not necessary to specify the data type anymore. Good. We end with a semicolon. Out. Continue. We are asked to use an if statement. If done is equal to 1, then all of this happens. Oh, if done is equals to 1, this player is incremented here. Okay, if done is equals to 0, then this should happen. Okay, that means here it was not necessary to increment the player by 1, because we first of all check whether the column is a correct number. So we remove that, and the condition enters, prints the number. Before incrementing, it passes through done. As we read here, what done does, we realize that done is a value returned to a GCE drop, 1 for a successful drop. So we first check the drop of the user before incrementing the player value. So that's a good modification to the code. We say if, let's put space, make our code look good. If done is identical to 1, I need to start accelerating out of time. Display grade, display grade, and I pass it in the C4 grade, as the pseudocode says. Next, I increment my player variable. Next, I say place disk. Place disk increment by 1 also, as it is said here. Place this equal to place of 1. Okay, we go to the else. Out of the if, we say else. What happens in the else is, oh, let's check this. Is it okay? Else if done is equals to 1. Else, guys, you have to work on your copy and paste to be extremely fast in typing code. Else if done is equals to, is identical to 0. Printf. I want to say chosen column is full. Go to \n to make our code look good. And to conclude, we have an else. Printf invalid column number, because here is just to check out invalid column number. Okay, invalid column number. Okay, this. Okay, with the semicolon. Let's check whether we have passed through all the constructs. Selection construct, invalid column number, good. And if out of all the ifs, you have to say align is equal to 0. Okay, out of all the ifs, good, we are out. Out of all the ifs, you say int align, because it wasn't declared. Int align is equals to is align, is equals to is align. This is true here. C4 grid, good. C4 grid. Out of that, we have if align is identical to 1. Next, we have if align is equal to 1 and disk is equal to x, which is identical. If align is equal to 1 and disk is identical to x, okay, that means you can just guess the next. What happens is printf, we have game over. Game over, player 1 wins. Always in this type of statements with \ends, because we know after something needs to happen, and we say stop becomes 1. Oh, sorry, stops becomes 1. Good. Next we have an else if, so we just copy this and we go. It's a kind of personal plagiarism. So we have else if align is equals to 1 and x is equals to O. Game over, player 2 wins, and stop is also equals to 0. Now finally we have an else. Print f error. Error says unknown player type. and it tells us to put a percentage d, comma, put the disk, comma, and we add this, and our statement with a semicolon. Okay, unknown player type, disk, that. Good. This is a format specifier. For this variable to come and be placed here, you need to put his format specifier, and this is a character. Good, so never forget that, else you're going to have a very big error. Now, you use this method going through everything before you start debugging, running, or compiling. When you are a pro in syntax, like you master the C syntax, all the syntax errors you master them, but we are still going to get some, so don't mind and just continue. Okay, out of the else we have printf unless end. Good, until stop is equal to 1. Okay, I think we're done with the loop. We get out of the while loop. This was our while loop. Out of the while loop here. Good. So out of the while loop, we continue. If stop is equal to 0, then print game over is a draw. Okay. If put inside the brackets, stop is identical to 0, a printf game is over, it's a draw. It's a draw. A tie, I mean. My bad. Okay. We end this. Okay. Print end it ends up. Good. Now the modulus operator in C is the percentage. Okay, is a percentage. Yeah, in our algorithm, I think we had mod, but in the C syntax, modulus is percentage. Good. So we are done. Go to the next question. Convert the algorithm in function. Okay, we have the 9 marks. In the subprogram play game, convert the pseudocode segment in tax 2 into a programming language code and insert weight indicated. Make the following adjustment to the program. Add statements which read for each player the column number they have entered into variable call. So we have done that already. Here it is, because our algorithm was not specified. So we have done that. Next, add 2 assignment statements which assign for each player character X or O that represents them. I've done that already. Here it is, and here it is. Good. So it was not precise here, so we just add, and I think even the input here is not necessary, so you can write your algorithm without this line, without the input lines. Okay, after doing the adjustments, okay, we have done the adjustments already. We have stored in the variable call, and we have made our disk to be, we have stored and we have made the disk to be initialized into X or O to represent them. Good. In, we have the 4 marks. In your main program, call the subprogram display grid. Let's first put our main program. The main program is simple. We have int main, and at the end we just have a return 0. Good. We have a main program now. We have to call the subprogram display grid to the connect for grid and subprograms play game. Okay, so we're going to call both of them using the C4 grid. So here we're going to have display grid C4 grid, and here we're going to have play game C4 grid. Okay, have all been called successfully. Save your source code as print2a and then print a copy. Source code. Okay, so we're going to change the file of our code. Here we are going to rename it to print2a in your candidate folder. Print2a. Print2a is a C file. We're going to delete the other one after. Run your program so that one player wins. Okay, let's run the program. I guess the number of errors we're going to have here incredible. Wow. Okay, the first error is at line 13 and it says expected this before 4. Okay, do it. Okay, another error, line 25. Define is not declared. Okay, define is an integer. Int define, and I is also an integer, so we do that. Next, 27, done is undeclared. Okay, done is an integer, you declare done. These are errors that you might not go back to the paper and check, because I guess done was not declared. So int done, which is an integer. Done. Okay, this is done. Done is being used. It is not a parameter. Done. Oh, the data type. Done being 0 and I equals to rows. Oh, I came and put define instead of. Oh, my bad. It's not define. It's done. Is there a define here? There's no define. Okay. Wow. So done is 0. I will move this one time. Good. Continue debugging. This will happen in the exam all moments. So let's do that. Empty character constant. Okay, it's usually a space. Next, expected this before the else. Wow. Oh, we need to go out of the if before put the else. We don't put the else in the if. So put this outside. Good. Next, place this undeclared. Oh, here's a comma. To make it an integer, we separate it with a comma. Next, expected identifier or this before the while. Oh yeah, we are out of the function. How is it even possible? So we need to cancel this and put it after the function. That means out of the while, out of everything, exactly here. Good. So now the while is in the function. X is a tons of errors. So okay, this is undeclared. This is undeclared. So we're just going to come here and put a certain char disk. But since it's a character, next we're left with about 27 code. Done is undeclared. Oh, the done are removed up here. It's supposed to be here. Done outside the loop, outside the else, outside the while. Int this, comma. Done is an integer, comma done. Okay. Next, expected is fire before the if. That means here we need to be out of the. Oh wow, debugging is crazy, guys. We're already out of the function. Why are we out of the function? It is the statement that says game is over is a type. Game is over is a type is inside the function. That means we should take this. That means we just paste that one in right direction. Okay, remove this and put it here. Good. Stop undeclared. Stop is undeclared, stop is undeclared, stop is undeclared. Okay, you need to declare stop. Stop is declared. Let's check whether we are in the function. Yeah, so it's a mistake at the level of the S capital, whereas here we have S small case. Okay, it's supposed to be small case, so we change that. Guys, I'm doing this because in the exam, no matter what you do, you're going to have errors. So I'm just trying to give you a hint or a kind of sneak peek of how debugging will look like in the hall. Okay, so next we have incompatible implicit declaration built-in function for printf. This is our printf. So what's happening here? This is the function. This is the first for. Oh, what is this? Okay, this is not supposed to exist. This is the first for. All of this should be inside the first for. That's how we display arrays. We end the first for. Okay, so let's go on it and see whether we have a mistake at that level. No. Good. implicit derivation function printf. Good. Out of the function. How? So we remove this. We are supposed to be out of the two for loops. Good. Incompatible declaration built-in function printf. Pass to the next. Go to line 45. It says warning, passing argument 1 empty grid. Okay, incompatible pointer type. Okay, wow. So empty grid, C4 grid. We are passing C4 grid in the empty grid function at once. Stop. Cut. Okay, continue. Wow. At this level, we are going to see there are a lot of mistakes around the line codes 40 to 50, 60, 70, 67. Okay, so there are a lot of mistakes inside this loop. Let's check that. Okay, let's check the sense behind the while loop. It said repeat until stop is equal to 1 or place disk is greater than 25. Whereas the condition that is usually put inside the while loop is the true condition. Like what should happen for this block of code to continue repeatedly. This is the breakout condition instead. Oh my bad. This is the breakout condition, whereas this is the true condition. Okay, so to do that, we are going to have the mistake, the opposite of the breakout condition. We're going to put this to 0, and we're going to put this to less than 24 because even this, the opposite of or is definitely an statement for the true. Less than 24 because it leads from 0 to 24. Less than 25, I mean, because stop place this from 0 to 24, which will make 25 plays for the user. So each time they play, this will happen. Okay, all of them being there, done is going to change, empty grid is going to happen. So okay, let's check that. The same mistake. Oh, here they say implicit declaration of built-in function printf. Printf is declared. Oh, my bad, guys, my bad. Anyways, let's change this. Before using the printf function and the scanf function, you always need to include the library responsible for that, which is the standard input output header. Okay, so let's put that hashtag include std io.h. Good. So we do that. Oh, sorry. Oh, the same mistakes. Hashtag in. Oh no. This will happen in the hall, guys. Don't be stressed. Just be extremely calm and go on. Okay, we left from 27 to 14 errors. Good. We move. As time is going, we are debugging. This is the most important part, guys, because if you look at they mark allocations very well. You have marks for specific functions, so that's what we are trying to fix here, and making sure that we're in phase with all the marking allocation. So we have an error at line 48 which says passing argument 1 integrate incompatible pointer type. Okay, we open the align.h file and we realize that here it takes tab as a parameter of data type cboard, c4 grid, c4 grid, c4 grid, c4 grid. So it's our global variable, and c4 grid is an array of size 55. Comes here is an array of size 55. It shows it completely. So let's run it again. Passing argument 1 empty grid from incompatible pointer type. Incompatible pointer type. Let's open back the candidate folder and open the align. Let's just open this align folder in our text editor. Yeah, so this is the align.h program. This is the cboard tab. It says it takes an array, subprompt to empty grid, takes the array tab and converts it. Okay, this cboard, let's check what it is. Oh yeah, cboard was a kind of data type we defined it. It was having macros already, so no need to do this here again unless you use a pointer to pass through the address. We're going to remove the size on the c4 grid. Good. Let's run it again. Good. We are left with 3 errors. Undefined reference to display grid. Okay, guys, my bad. Display. So it's a display grid mistake. Okay, that's it. We run again. It's a mistake. Okay, finally it runs. So we enter 1, enter 2, enter 3. Okay, you can see the way space analyzed exactly thanks to the spaces we're able to put on our 1, 2, 3 rows and columns. Here we put a space after the %c, and here we put 3 spaces. So make sure that it's displays well. Let's check it again. 1, 2, 3, 4, 5. Oh, 5 is printing right in front of you. Wow, there's a problem with 5. Let's check why. Okay, here we are going to see because the column position, there's a problem with the column position. 5 is not going at the 5th column. Realize that even column at the beginning is 5, and our condition says column should be less than or equal to this number, and we realize that column is greater than or equal to 1 depending on what the user inputs. So when I input 5, it goes to the first position, which is bad. So I'm going to subtract 1 here and subtract 1 here to be sure that 1 is going to index 0, 2 is going to index 1, because if the user inputs 1, that 0 will index 0. So we subtract all the inputs of the user. Okay, we run that back. 1. Okay, at least it's at the beginning. This time around it's at the beginning. 2. Good. It continues. 3, 4, 3. 3 goes at 2. 5. 5 goes at 4. That's still good. So to change that, we're going to place these guys in their appropriate positions. Okay, we just put 1 space around. Let's try and put the space by printing the columns. 1 space before the percentage C, or it's percentage C, yeah, a space before the percentage C. Let's put a space before the percentage C to format our code well. space there is going to cause troubles. So let's do it like this instead. 1, 2. Okay, I see there is a problem exactly on our spacing. Yeah, let's just put a space here so that it leaves a space after printing 1, after printing 2. Good. So 1, exactly. 2, good. 3, good. 4, good. 5, good. Good. That's it. Let's believe the code is running, and let's go to the last part of the question. Debugging done successfully. We come back here, and the last question says run your program so that one player wins. Take the screenshot, save it as the file, print out 2B, then print a copy. So we are going to run it. For one player to win, let's make player 1 to win. We are just going to print 1, 2, 1, 2. Player 1 is going to play 1, player 2 is going to play 2. Okay. Oh, after this guy plays, there's a problem here. Error unknown player type X, unknown player type O. It prints it always. Let's go back to the error section. Here's the error section. Okay, we have the else if. So after going through the code thoroughly, I realized there is no error because everything was exactly placed the way it was. And also there's an error. This particular code segment is very unnecessary because when playing, if the user inputs something like 8, you're going to see invalid column number, player 1 turn to play. I enter 8 again, invalid input invalid column number, players 1 turn to play. If I enter W, it enters a while loop and an infinite loop, because it doesn't check for the condition. So we are just going to allow the code as it is because the algorithm tells us to do so. For this type of error, if you want to correct it, we'll have to change the logic of the whole code. So given that this is reflected at every part of our code, we are simply going to run the code and make a winner from any player and print the output. Let's do that. 1, we go 2, 1, 2, 1, 2, 1. Okay, game over. Player 1 wins. When player 1 wins, we take a screenshot. We are going to invite our snipping tools. We are going to invite snipping tools by searching on our toolbar. Once you have snipping tools, you click on new. Friends, while screenshotting, always avoid this part because it shows the file path to your document, and usually your file path has the name of the computer, which might be the center name, and your file name, which is your name, and any disclose of identity from the instructions is going to penalize you or might cancel your whole result. So to screenshot, you start exactly here. You take just a segment of the code that run, and that's it. You're going to save it in the candidates folder as printout2b. Okay, we're in the candidate folder. I'm going to say print out 2b. Save. Okay, that's it. We are done with this execution part. You have analyzed the code, you have done everything the way it's supposed to be. Now let's go to a conclusion. Our conclusion. So we have come to the end of this paper, which was the section B of the GCE Computer Science paper 3. We have come to the end of this paper. Thanks for watching. Comment below for any question or any suggestion. Don't forget that it was a proposed solution. 1 like equals to 1 prayer, 1 share equals to 1 miracle, 1 subscription equals to 1 blessing. Altogether gives 1 more video. Going to join our Telegram group by entering the link in the description. Email us through here and stay curious and keep learning. You're on your way to greatness.